Hello everyone, welcome to SQL Depository, and today we are going to discuss basics of indexes in SQL Server. So I have a small select statement here where I am selecting three columns: sales order ID, product ID, unit price from sales.SalesOrderDetail table. So I'm gonna execute this SQL statement along with the actual execution plan. So let me go ahead and click on execute. And once this will be done, I can look at the plan. And here I can see two operators. One is clustered index scan and second is select operator. So what I'm gonna do now is I'm gonna create a new index on this table, and then we will see if it improves the performance of select statement or not. So I'm going to create this index here, which is ix_1 on sales.SalesOrderDetail table. And I have kept sales order ID, product ID, and unit price in the index key column list. So sales order ID first, product ID second, and unit price third. So I'm going to go ahead and click on execute. And once this index will create, I will run the select statement one more time. And once this statement execution will complete, I will go and look at the execution plan. And this time again, I can see two operators. But instead of clustered index scan, I can see index scan operator. And you can also see under the object that it is using my index, which I have created just now. And it is ix_1. And if you look under the object, you will find that. Now, it is using my index, which is very, very good, but is it improving the performance of the query? So to identify that, if there is any improvement by this index or not, what I'm going to do here is I'm going to run the exactly same select statement twice, one without any query hint, and second one with the index hint. And here I'm forcing SQL statement to use the cluster index. So let me go ahead and execute both these statements together. And now look at the execution plan. Here you can see the first query is using the batch cost of the first query is 29% and batch cost of the second query is 71%. So you can clearly see where it is using clustered index scan. The query cost is higher 3 times in comparison to the batch which is using my index. So there is definitely some improvement, but how and where exactly it is providing the improvement? To identify that, what I'm gonna do now, I'm gonna go back here and going to enable the IO stats. So the command is set statistics IO. Oops, it is IO off. So let me go ahead and change it to on. And now if I'll execute this, it will enable the IO stats. And now I will run both the queries together again. This time I don't need the actual execution plan because I will look at the messages. And let me go ahead and execute this. And once it will be done, I can look at the message. And here I can see the first query is performing 397 logical reads. And second query is performing 1238 logical reads, right? So don't look at the physical reads now because when you do first time, you may see physical reads, but if you'll run it again, you will not find those reads again. Okay, so as you can see here, so from the next time it will be only logical reads, and this is what matter most here. Now, logical reads are 3 times lesser than the logical reads when it is using cluster index scan, right? And this is what exactly we have seen in the execution plan also. The batch cost of the first select statement where it was using ix_1 index, the batch cost was 3 times lesser than the batch cost of the same select statement where it was using cluster index. Okay. So it is improving the IOs, and this is where it is giving me the improvement. So I'm going ahead to disable the IO stats now. But do you have any answer how exactly my non-cluster index helps SQL server to perform less number of logical reads for this select statement where I'm selecting 3 columns from the sales.SalesOrderDetail table? So the answer is cluster index is your actual table and it has to contain all the data, which means it will contain all the columns. So it can fit less number of rows in the single page. While my non-cluster index has only 3 columns, so it can actually fit more number of rows in the single page. And because of this, you can get same amount of data by performing less number of logical reads because they are accommodated in the less number of pages. Correct? So this is how non-cluster index is improving the performance of my query here. But now I'm going to change my query a bit where I will include a where clause, and I will have a where clause on product ID column. And I'm declaring a variable here and passing the product ID. So let me go ahead and execute this along with the actual execution plan. So let me enable it again and execute now and look at the execution plan. So I can see a missing index detail here. So just ignore it for now. But you can see the index scan here and it is still using ix_1 index, which is what we have created at the starting of this video, right? Now, earlier you had no chance to convert this index scan to index seek because it was selecting all the rows from the table. However, not all the columns, but all the rows. And there was nothing that can convert this scan operator to seek because it has to get all the rows anyway. Okay, so it will anyway perform the scan operation, but this time this is not the case. This time we have a where clause on product ID column, so why it is not performing the index seek? If you look at our index that we have created at the starting of the video, it has product ID column, but the product ID column is second in the key column list, right? So this is our key column list. Whatever column names I will give here, they will be the key columns for this index. And sales order ID is the first key column, product ID is the second key column, and unit price is the third key column, right? So product ID is second in the key column list, but I'm gonna create a new index where I will keep product ID as the first key column here, right? And after that, I will have unit price and sales order ID as well. So let me go ahead and create this index and I will run the select statement one more time. And this time in the execution plan, you will see an index seek, and also you will see under the object that it is using ix_2 index, right? So we have converted index scan to index seek by changing the order of the columns. And this is why order of the columns in the key list is very, very important. Okay. And you should always check what column you should keep first, what column you should keep next, or what column is not at all required in the key list. You can actually use your covering index to cover the columns that are only part of your select list and not being used in anything like where clause or join condition or order by clause. So if that column is not part of any such thing, you can always use covering index. So I'm going to create a new index now, which is going to be a covering index. And if you look at the column names, it has the exactly same column: product ID, unit price, and sales order ID. Okay, but this time only product ID is in the key index list, but the unit price and sales order ID is in the include list. And this type of indexes are known as covering index. And let me actually go ahead and create this first and run the select statement one more time, and then I will tell you why exactly I am doing it. Okay, so go ahead and execute the same select statement one more time. You have an index seek, but this time you will see under the object, it is using ix_3 index, which we have created just now, right? So first, why should we do that? Okay, so ix underscore 2 and ix underscore 3. The only difference is in ix underscore 3, there are two columns that are part of the include list and not part of the key columns of the index, right? So I'm doing it because if you look at my select statement, I have only where clause on product ID column, and I just need the column values of sales order ID and product ID. So I don't need any sorting on the basis of sales order ID or it was not product ID, it was unit price. So sales order ID and unit price is required only for this select. There is no where clause on it. So I just need the value of it. So which means I don't need these values of the column sales order ID and unit price in a sorted format. It is not required. So I will keep it in include list, and when I will keep it in include list, SQL Server will not perform any sorting on the basis of unit price and sales order ID. Okay, where exactly it will give me the benefit? To identify the benefit, what I'm going to do here is I'm going to run these two queries again together, where in first query, I will not use any index hint, but in the second query, I will force SQL Server to use ix underscore 2. So first query will use ix underscore 3, which is the covering index, and second query will use ix underscore 2, where all the columns are part of, where all the columns are part of the index key column list. So let me look at the execution plan, and here you can see the batch cost, which is 50%, 50% in both the cases, which means SQL Server is not expecting any improvement when it is using ix underscore 3 instead of ix underscore 2. Then what is the need of converting this index into the covering index? We can just keep all the columns in the index key list. So we are not doing it because when we keep all the columns in the index key list, it will have to sort all the values on the basis of all the three columns. Now it will make your insert operation and DML operations more costlier, because whenever there is any insert, it will have to perform the sorting on the basis of three columns, and it will make your sorting even more complex and costlier. So you can still get the same performance by covering index, but at the same time, you will not make your DML operations much more costlier. Then why not we go ahead and create the covering index? This is why it is very much important to choose your key columns wisely. And whenever you don't need any column in the key column list, but you just need it for the data purpose, and as it is part of the select columns, then just keep it in the included list and create the covering index, right? So now what I'm going to do is I'm going to drop this ix underscore 2 index, okay? And I'm going to change this ix underscore 3 index a bit, where I will keep product ID as a key column, but in the include list, I will only keep sales order ID and remove unit price from the covering columns or include columns. So I will go ahead and execute this. Now I don't have any ix underscore 2 index. Ix underscore 3 index has been modified. Product ID is the key column, and sales order ID is the only column in the include list. And now if I'll go ahead and execute this query again, and if I look at the execution plan now, we are back to index scan, and it is using ix underscore 1. And this is why we are forced to do index scan, because product ID column is at the second spot in the key column list, right? So it cannot perform the seek on the basis of product ID. Now we still have ix underscore 3 index, which has product ID column as the key column. But the problem with this is we only have sales order ID in the include list, and we don't have unit price. So what I'm gonna do here is I'm gonna give the index hint with index ix underscore 3, and if I'll execute this statement again, the SQL Server is now forced to use ix underscore 3 index, but this time it will have to perform a key lookup. Now what is the key lookup? It is using the index ix underscore 3, which has no clue about the column unit price, but select need the value of unit price as well. So it will have to go to the cluster index and ask for the values of unit price. And for this, it will have to perform the key lookup. And if you look at the actual number of rows read and actual number of rows for all execution, it is 228, which means it has to do 228 round trips to cluster index to get all the unit price column values, because it is returning 228 rows, which you can verify here. And if you don't want to verify here, then you can also go ahead and verify here. Your index, it is returning 228 rows. Even if you look at the select, it is getting 228 rows as the input. Okay, so for these 228 rows, it will perform the key lookup 228 times, and which will make my cost, the cost of the query even more complex. It will increase the cost of the query, and it will even reduce the performance of my select statement. Okay, so this is why SQL Server decided not to use ix underscore 3, but here I have used the index hint to use ix underscore 3, but it is not optimal for sure. So what I'm gonna do now, I'm gonna drop the ix underscore 1 index as well. And now we don't have any ix underscore 1 index as well. And if I'll execute this statement one more time and look at the execution plan, here I can see the cluster index scan is back, because it is thinking that it is okay to do more logical reads, as we have seen earlier, that in case of cluster index scan, it will perform more logical reads. But it is okay to do more logical read, but it is not okay to perform the key lookup. And this is how your key lookup is costlier. The key lookup operator is always costlier. Sometimes it is okay when it is just fetching a single row or two rows, and it has to do only a single round trip to the cluster index to get the values. In those cases, SQL Server may still go ahead and use the key lookup in the plan. But otherwise, if the number of rows are high, in that case, it will never use the key lookup. Now, suppose a scenario where you are using a stored procedure, and when you compiled the plan, you have used a input parameter where it is returning only one row, and because of that, SQL Server decided to use a key lookup. But for the other parameter values, it was returning few thousands of records, and then it has to do a key lookup for those 1,000 records or a few thousand records, and then your procedure has started to perform suboptimally or poorly. So this is what happens, because your SQL Server will reuse that plan in case of procedure or parameterized queries, and this is known as the parameter sniffing that I will cover later. But this is why you should always try to avoid key lookup, because you don't know, maybe a key lookup is fine for one parameter value, but someday or for some parameter values, it will start to decrease the performance, and you will have a great degradation of the performance in your SQL Server. Okay, so next thing that I'm gonna do is, you have seen that when I've removed the unit price, because of the unit price, if it cannot use, it could not use ix underscore 3 index, because it does not want to perform a key lookup. But what I'm gonna do now, I'm gonna recreate the index again, and this time I will include unit price, but I will exclude sales order ID column, which is here. So earlier we excluded unit price, this time we are excluding sales order ID. So let me go ahead and execute this, and I will go ahead and run this select statement one more time. And this time I have an index seek, because it is using ix underscore 3. However, I did not give sales order ID column in the include list, but it did not perform any key lookup, and still it used ix underscore 3 index, and it is performing index C. So why this is happening here? For unit price, it was performing key lookup when using this index, but now it is using the same index, which has no idea about sales order ID column, and it is still doing index seek without any key lookup. So the answer of this question is, you have the cluster index on sales order ID column, and you don't have to include the cluster index column in your non-cluster index include column list, because this value will always be available. But if you have the requirement to keep it in the key column list, then maybe you still have to involve that, but you never have to include this column in the include list of the non-cluster index if the column is if the column is cluster index and cluster index has been created on the top of it. Okay, so this is why we could exclude sales order ID without hampering the performance, but we could not exclude unit price without hampering the performance. Okay, so this is what I wanted to cover in this video. If you want all these scripts, I will give the scripts in the description below. You can copy all these scripts from there. And I have used AdventureWorks 2022 database, which is easily available on the internet. You can go ahead and download that database and store it in your environment and run these SQL statements, and you will find the exactly same result. So go ahead, copy those commands and practice in your environment.